Hello everyone. For our last video here, we're going to be looking at this concept of polymorphism. And to get started, when we define a class to implement the interface, we're going to take a variable or parameter, such as a reference of the interface type, and assign an object of that class to it. And for example, when we use arrays sorting method, we would sort different kinds of objects as long as they had this comparable interface. So there needs to be something a bit similar for these things to behave a little bit, such as implementing a similar interface, even if they're different items, such as one of them might be like a car class or might be a van class. But if they have a comparable interface implemented, then we can use the same method on them. What this means here in a term is polymorphism, which is where the variable type of behavior of the sort methods depends on the type of input. Now, we can do polymorphism without doing interface usage by using inheritance. And we achieve a similar polymorphic behavior, but it's slightly different in how it's going to be approached. So what we do here for inheritance is that if we create a reference or a variable of a base class type, so for instance, if you have an abstract class like vehicle, like we saw in this lecture, we can assign any object of any derived class to it. So in our scenario, this would be vehicle, this would be van. Now, what happens if we assign a derived class object to a base class reference and then call a method? Which does it come from? You'll see that there's a few different possibilities here, but the main one that we're going to be looking at here is this last one. If the method is abstract in the base class, which vehicle was abstract, and defined in the derived class, and again, because it's abstract, it can't be defined if we're making an abstract method in the base class, and if the derived class is extending that abstract class, it must implement that method. What happens is that the derived class version will be used. So now what happens here is that we're going to have different outputs based on something, and we can actually make some interesting code work a lot better for us. So now we could say the version of any overridden method called by a reference like this will be based on the type of the object the reference points to, not the type of the reference itself. And in terms like simpler terms, what this means is that if I create a vehicle object called new car, this is the reference to the vehicle class, and its base type or its derived type is van. What happens when I call drive forward and get speed? Or excuse me, what happens when I call drive forward and get speed is I'm referencing these methods here, not these methods. Now, this is the same in previous inheritance examples that we've seen. It might be easier here though, because you'll notice that there's no code being implemented whatsoever. But again, these are the calls being called here. So if we go back to our code here, in general here, when you want to make abstract classes, you can automatically invoke the different versions of a method from one polymorphic reference. Now, this is going to be super interesting to us, and let's see how this will actually work. So what I'm going to do for us is I'm going to make two more types of cars. I'm just going to make a car class, and it's going to extend vehicle, excuse me. And now I'm going to have to add in these unimplemented methods, and I'm going to kind of briefly just do this more quickly. So I'm going to say public string color, and this is its car. We're going to keep the same ideas here. We're going to get the get speed, and what I'm going to say here is car going, and let me go ahead and just grab up this return statement. And you'll see how quickly it is to implement a different class with a few different things here. We'll see already that we're pretty much have this car class done based on this extension. What I'll do is I'll do one more. I'm going to do a truck. So I'm going to do truck class. It's going to extends vehicle like so. And what methods do I need to implement? Well, I'm going to add in that method again. I'm going to go ahead and just copy and paste this one. I'm going to say truck going miles per hour. And then what I'll also do is I'm just going to copy over these two guys too. So again, this will be done for you in your Java files, but if you want to code them along, I think it's very good practice for you. And what we could see here now is let's go to the vehicle driver class. We'll see that I'm doing all this work here for the get speed and the get methods. Let's go ahead, and what I'll do here is I'm actually going to replace this. Instead of saying new van, I'm going to call one as a van, one as a car, one as a truck. And then what I'm going to say here is create derived variables, new van, new car, new truck. And what I also want to do here is I'm going to briefly add into the drive forward. So I'm going to make each of these guys increase by speed here. And what I'll briefly add in is a simple print line statement into each of these methods that just says which class I'm in. So I'm going to say in van. And let me, oops, it looks like I forgot to actually increase my speed in each of these guys. So let me go ahead and do that really quick as well. This one is going to say in car because I'm inside of the car class. This last one is going to say in truck because I'm inside of the truck class. Like so. Now, what I want to do here is we'll notice that I have a lot of code here. And yeah, I could technically do a bunch of print statements, try to get it to work. But what happens here if I go ahead and instead of just making each of these individual lines of code to try and increment them, what if I make a vehicle array called vehicles and I set it equal to the array objects of new van, new car, and new truck. Now we'll see here that my vehicles class is actually working really well. And what happens here if I go ahead and try to say, oops, instead of doing a print statement, or actually I'll leave that in there. Let me try to get the new van.getSpeed. Let's just see if this is going to run for us first. Okay, I get van going 15 miles per hour. How about I do a for loop here? So I'm going to say for int of I is equal to 0, I is less than vehicles.length, I plus plus. But what I'm going to say here is, you know what I want to do? I want to increase each of these guys by 5 miles per hour in this for loop. So I could say here, vehicles of I dot, not get speed, but dot drive forward. And now without looking at the visibility, if I change this to private, like so, I wouldn't be able to do this as easily. For simplicity's sake, just go with the public so the visibility isn't a huge issue right now. Now, what will happen if I go ahead and I try to run my get speed now down here? Everyone sees here that each time I run this .drive forward command, I actually call from each of these individual methods the in car, in truck, and in van. Now, why is this useful for us? Well, what I can say now here, very briefly, how about I want to make a program that says, what if I have 400 different vehicles and I want to get the speed of every single vehicle that's going on, and I have no idea how many vans or cars or trucks I have? And let me change this to orange, green. What I could say here is essentially vehicles of I dot get speed, like so. And if I run this one, oops, let me go ahead and actually print this out as well. Perfect. We'll see now that I go through each of my methods of my cars, and I'll say I have a van going 20 miles per hour, car going 20 miles per hour, truck. And you know what, to make this even prettier, what I'll say here is I'm just going to add the color as well. So I'll say green van, or it's a blue van. Let's add this in really quick. Maybe sky. Cool. Blue van going 20 miles per hour, orange car going 20 miles per hour, and green truck going 20 miles per hour. And each of these are being called from their own individual methods over here. So this, in an essence, is what polymorphism is, and it's a super powerful tool, and you're really going to be seeing it when you get into more software development level courses and making some more apps as well with it. So again, abstract classes are extremely useful. They're a very nice twist on inheritance, and they make it a lot easier to implement methods, a lot less code, and you can see here how creative we got with our vehicles, all because of a simple abstract class that we created over here. One thing to note, though, is that if I change this vehicle array to a car array, now these guys are going to have an issue because I can't convert from vehicles back over to it like so. So just make sure that you're aware of this and that I'm using the base class of vehicle, which is abstract, to implement it like this.